5 million people starved in Russia in 1921 due to famine and crop failures. Another 5 million died in China between 1928 and 1930, and 3 million perished in Bengal in 1943. Different nations, different crops, but the same invisible enemy. Microscopic spores of fungus and disease, destroying harvests, turning fields into dust and villages into graveyards. At the dawn of the 20th century, humanity had no defense, until a farm boy from Wisconsin stood against this tide of devastation and gave our crops a defense. He made seeds fight back, and agriculture found its champion in an invisible war. This is the story of John Charles Walker, a scientist, a visionary, who waged a war against the invisible enemies that destroy our food, pulling humanity back from the brink of starvation. Walker was born in 1893 at a farm in Racine, Wisconsin. His father grew cabbage and sold seed. As a young farm boy, he watched crops fail, cabbage rot, onions smudge, peas wilt. It wasn't just bad luck, it was a lack of resistance. He vowed early that science would be his weapon against this invisible enemy. In 1910, he began his studies at the University of Wisconsin, earned degrees in plant pathology, and by 1918 had his PhD in plant pathology. Early 20th century vegetable farmers faced disaster. Cabbage yellows were unpredictable. Onions had smudge, neck rot. Beans were ravaged by mosaic virus. Farmers had few tools. Chemicals were unreliable or expensive. Nutrition was poorly understood. Walker observed not just the pathogens, but plants. Why did some survive? He asked, what if the defense could be built into the seed itself? Walker made several key breakthroughs. Here are the big ones. Walker's most powerful weapon was genetic resistance. Until then, most plant disease control meant spraying chemicals or rotating fields. Walker asked a radical question. What if we build the defense right into the seed itself? He began crossing plants that survived outbreaks with those that didn't, generation after generation, until he created lines of beans, peas, cabbages, onions, and cucumbers that could literally shrug off viruses and fungi. This wasn't just traditional breeding. It was one of the first times anyone proved you could breed vegetables specifically for resistance to multiple diseases at once, and then show the inheritance patterns behind it. Some of the famous examples: beans resistant to mosaic virus and halo blight, cabbage resistant to yellows, onions resistant to smudge and neck rot, peas with built-in protection from wilt. Those resistant genes are still embedded in many of today's commercial varieties. Without his work, we'd be spraying a lot more chemicals and losing a lot more food. He discovered that certain pigments and plant chemicals, phenolic compounds in onion skins, correlated with resistance to smudge and neck rot. In short, color and chemistry matter. He showed that soil nutrients, example boron, temperature, even outer layers of plants' nutrition, all influence whether disease takes hold. It wasn't just add chemical fungicide, it was tuned biology. His work saved industries. Cabbage growers in Wisconsin got yellows-resistant varieties. Bean breeders got virus-resistant beans. Growers of peas, cucumbers, onions all benefited. Seeds of his resistant varieties spread. But Walker didn't just do experiments. He trained the next generation. He guided over 75 graduate students from Wisconsin and abroad. Many went on to lead plant pathology in other countries. He wrote 2 major textbooks, Diseases of Vegetable Crops and Plant Pathology, references that scientists still use. His work gathered global recognition. He was elected to the U.S. National Academy of Sciences in 1945, honorary doctorate from the University of Göttingen in Germany, the Wolf Prize in Agriculture in 1978, and many more. But perhaps more importantly, the real award was in seeing disease losses drop, supply stabilize, food quality improve. Fast forward to today. Climate change, new pathogens, soil depletion. Our food systems are under pressure. Walker's legacy, breeding for innate resistance, focusing on nutrition, environment, is more relevant than ever. Every disease-resistant variety you eat, beans, peas, onions, cabbage, is often built on the foundation he established. Without his work, we'd spray more chemicals and lose more food. Seedsmen, scientists around the world still use his methods. In many ways, what Walker did was plant the seed for modern sustainable agriculture. John Charles Walker passed away in 1994 at the age of 101, but his work still feeds millions every single day. If stories like this inspire you, help us bring them to more people. Subscribe now, hit the bell, and share this video with friends, classrooms, and communities who care about the hidden heroes behind our world. Your support lets us uncover and tell more of these untold stories. This is Awards, where the world's greatest minds live forever. Don't just watch history. Be inspired by it.
Thanks for being with Awards. Subscribe to know more about international award winners and unsung heroes behind peace, science, and humanity.